Hello all. So today we are going to learn about limit laws. So in my last session we discussed about what is limit and what is important. So we consider limit as a backbone of calculus, and understanding the basic concept of limit will help definitely in understanding the complex part of the calculus. So in last video I explained about that this helps in finding out area under a curve, or whether a curve is continuous or not. And I'll provide a link to my old video, like, so that you can refer back to what we discussed in the last session. Today we are going to focus on limit laws. So there are different laws which helps in deriving limit. So let's go back to the lesson and we'll see with example how we can find out limit in different algebraic expressions. So today we are going to learn about limit law. The very first law is limit of sum. So limit of sum is what it says that if we are finding out limit of the expression, and a limit of expression, and then we can very well do the same limit by finding out limit of individual. If we can derive individual limit, and then we can find out sum of those limits, that will give the equal results. So if you look at here, what it say that if limit, we are trying to find out limit of expression which is consisting of two functions fx and gx. For example, we have mentioned here what is fx and what is gx. Then if we are trying to find out when x is approaching a, the value of this uh, two sum of the two functions, then very well we can do the same thing. The result will be same if we find out limit of each function when x is approaching a, and limit of this function when x is approaching a, and then sum them together. So let's take with the example. So here in this example we have a very simple expression function where first one is fx is equal to x square plus 9. Second is gx, which is cx 6x, and hx is 6. So first one, when we are trying to find out limit of fx plus gx as x is approaching 2. So let's find out limit x is approaching a for fx. So this will be, if x is approaching 2, right? So it will be 4 plus 9, 13. Similarly, if we find out gx, limit x approaching a 2, in that case it will be 6 times 2, 12. So the answer to this one will be just sum of these two. So 13 plus 12 equal to 25. Let's take another example where fx plus hx. So now this fx we already found, and hx, because it's a constant value, so limit x is approaching 2 is going to remain as 6. So answer for this question will be 13 plus 6 equal to 19. So once again, if we want to find out limit of a sum of two functions, then very well we can find out limit of each function as x is approaching that value, and then to sum them together. Let's look at few more laws. So next law is law of difference. So law of difference is similar to, very well similar to law of sum. Here it says that if we need to find out limit of subtraction or difference of two functions, then we can very well find out limit of the same function independently, and then make, do the difference later. So same example, if in the previous page we find out the limit x is approaching 2 for x square plus 9 was 4 plus 9 equal to 13, and for this one limit x is approaching 2, 6x equal to 6 times 2 is 12, So now in order to find out this, we have to just say 13 minus 12 equal to 1. Another example, hx, in this case hx value will be same, with x is approaching 2 or any value, it's a constant. So here we have to say 13 minus 6 equal to 7. So once again, let's look at the law. It says that if we need to find out limit of difference of two functions, then we can find out limit of independent function approaching the same value and then do subtraction. Let's look at the third law, which is law of limit of a product. On the similar line to subtraction and addition, we say that if we need to find out limit of a product of two functions, then we can do very well find out limit of independent function and then make a product out of that. So limit of the product of the is the product of the limits. Same function what we considered on the previous slide. So limit of x approaching to x square plus 9 is going to be 4 plus 9, 13, and gx, if we need to find out limit x is approaching 2 is 6 times 2 is equal to 12. Now we need to find out limit of x and gx approaching 2, which is product of this one. So we can find out 13 times 2, and whatever value it comes, that will be the answer. This is going to be. Next is if you need to find out product where one part is constant, so this is also on the similar line. We can do 4 times and limit x is approaching 2 fx, which is x square plus 9. So it will be 4 times 13. We already calculated here. So whatever it comes, I think it's come 52. So let's repeat or summarize limit of a product. So if we need to find out limit of x approaching a value and for two functions, then we can very well find out individual limit for the same x approaching a and then make a product out of that. Okay. Let's look at limit of a quotient. So in case of quotient, limit of a quotient is the quotient of the limits. So if we need to find out limit of where the expression is product quotient of like two expressions, then we can find out individual limit. One important thing we need to consider is in this example, the value of gx should not be 0 when x is approaching a. Then only we can apply this law. So as we discussed previously, the limit, let's find out limit of x approaching 2 when for this function x approaching 2 for x square plus 9. So this will be 2 square plus 9. So 4 plus 9 is 13. And limit of x approaching 2, 6 times for this function, 6 times 2 is 12. So in this case, because this is when x is approaching 2, this is not 0. So we can very well find out quotient as 13 over 12. There is another example where one of the function is a constant value. In that case, is similar law can be applied. So fx in this case, fx when limit is approaching x is approaching 2 is 13. We calculated here, and we are dividing with 4. So if this answer for this one will be 13/4. It's a fixed value. So once again, let's revise it. If we need to find out limit of a quotient which consists of two functions or a constant value, then we can very well find out individual limit and then divide them together. Let's look at another law, limit of a power. So if we need to find out limit of a power, then that is same as finding limit of the function and then making the same power. Let's take example. So this is x plus 3. So limit x is approaching to fx, which is equal to x plus 3. So this value will be 2 plus 3, 5. So if we need to find out limit of x approaching 2 for this function and power is 2, then we can do inside this, we already calculated this 5 and then make a power of this. So 25 is going to be answer. Let's summarize. If we need to find out limit of x approaching a value for a function that consists and the power of that, then we can find out limit of the same function and then make a power later. Okay, let's look at limit of a root. So limit of root is the root of the limit. So if we need to find out, for example, in this case, x is approaching a and is nth power of the fx, then we can first find out limit and then do nth power after that. One important thing we need to remember is that n is a positive integer in this case. Then only we can apply this. Let's take example. So in this case, suppose we need to find a root of fx when x is approaching 6, then first find out limit of x approaching 6 for fx, which is x plus 3. So we can substitute value 6 plus 3 equal to 9, and now we need to find out this. Then this is same as taking root of limit x is approaching 6 fx equal to this, we calculated 9, so 9, so this will be 3, and we can do like plus minus, both values are possible. So let's look at another law. Actually, this is a law for substitution. If there is algebraic expression, then and there is no quotient, in that case we can do some direct substitution. So for example, if we need to find out when x is approaching 2 and for f2, in that case how we can do that? So just replace this value 2 to the power 5 plus 2 to the power 4 minus 2 to the power 3 plus 3. That gives me 32 plus 16 minus 8 plus 3. So this is 8, this gives me 8, so 8, 11 and 11, 43. That's the answer. Okay, so now let's find out combination, like we can use multiple laws together in order to find out limit. So in this expression, so it's x cube plus 2x squared minus 1 divided by 5 minus 3x. So if you need to break out, then what we can do? We can do, let's apply limit of quotient. So x is approaching 2. We can do x cube plus 2x squared minus 1. And here x limit x is approaching 2, 5 minus 3x. Now let's apply substitution law, because this is algebraic expression. So on the top we are going to replace 3 plus 2. Actually x is approaching minus 2, so let's put minus sign here, minus sign here, minus 1. That gives me minus 8. This is 2 minus 4 and minus 1. So that is minus 8 minus 4 minus 1 equal to minus 13. And for this one is going to be 5 minus 3 and minus 2. That gives me 5 plus 6 is equal to 11. So in order to find out this expression, now we can do this substitution and quotient law together. That gives me minus 13 on the top and 11 on the bottom. This is going to be my answer. Okay. Another one is finding limit of a polynomial using direct substitution. So as we seen the previous example, then let's take one more example. Now we have here like power also. So it's again combination of different values. So if we need to break this one in by law of quotient, then we can do x minus 1, x4 plus x squared minus 6 divided by limit x is approaching 1, x square x4 plus 2x plus 3, and then using the law of power we can do power later. So that gives me if we are substituting here directly, so 1 to the power 4 plus 1 to the power 2 minus 6, and bottom is going to be 1 to the 4 plus 2 plus 3, and let's keep this power. That gives me 1 plus 1 2 minus 6 is minus 4, and here is going to be 1 plus 2 3 plus 3 6. This is going to be, and we can very well simplify this one. So it's going to be minus 2 over 6 minus 2 over 3 and to the power the square. This gives me 4 over 9. Okay, so I hope you are following me. Finding limit using algebra and limit law. So there are few more examples. Here we need to find out x is approaching 1 and this x minus 1, x square minus 1. So let's look at this. So one important thing is if you look at here, x is approaching 1, then it becomes 0. So we cannot do direct substitution. We need to find out differently. So let's simplify this equation. So x minus 1 on the top. Bottom, if you look at, we can see that x square, there is a, we know formula a square minus b square equal to a plus b, a minus b. So here we can mention x minus 1, x plus 1. So this can be cancelled out. So basically now we need to find out limit x is approaching 1, 1 over x plus 1, which is simpler, 1 over 1 plus 1, that is 1 over 2. That's answer for this one. Let's look at the second example. So 3 plus h square, 3 plus h, and there is square of this one minus 9. So in order to find out this, what we are going to do, let's use the same formula to break it out. So we can say 3 plus h plus 3, and this is 3 plus h minus 3. Bottom is h, so this becomes 6 plus h. This is just h over h. This gets cancelled out. So limit of x approaching h approaching 0. Now we need to find out 6 plus h. So that is 6 plus 0.